Welcome back to Applied Mathematics. In this video, I want to talk about writing proportions. As we've seen in our study of similar figures, proportions are a powerful problem-solving tool. In this video, I want to explore some other cases that are not necessarily geometric figures, where things scale proportionally and we can use that to our advantage. Let me get my head out of the way and let's dive in. A map scale indicates that 2 centimeters on the map corresponds to 5 kilometers in town. How long should the line on the map be to depict an 8.5 kilometer nature trail? This is an interesting problem, I think, because it's essentially a similar figure in disguise, right? A map is a scale drawing, a similar figure to the world around us. So with that in mind, it becomes fairly obvious that this is going to be a proportion that we can write and solve. The map scale, 2 centimeters on the map, corresponds to 5 kilometers in the world. The nature trail has an unknown length on the map, but corresponds to 8.5 kilometers in the world. Using the cross product test from here, I get that 5x is 2 times 8.5 2 times 8.5 is 17. 17 divided by 5 is 3.4. And let's see, that was a measurement on the map. Measurements on the map were in centimeters, so this is also going to be in centimeters. That's it. That's all there is to it. As I've mentioned previously when we were talking about similar figures, one of the issues with solving problems with proportions is there's more than one right way of setting up the problem. In this case, I've set it up so that the first fraction was things that have to do with the map, and the second fraction was things that have to do with the actual town. The numerators of the two fractions also match up. They are the scale on the map. The denominators of the two fractions match up. They are the nature trail. So making sure that your fractions line up, making sure that your numerator and denominator line up as well, will give you something that works. But we could have done it the other way, right? I could have set this up using the map scale as my first fraction, 2 centimeters in the numerator, 5 kilometers in the denominator. Then the nature trail would be my second fraction, unknown length on the map in the numerator, 8.5 kilometers in the denominator. And this is a very different looking proportion. The interesting thing about it, though, when you take the cross product test, you're still going to get 2 times 8.5 is equal to 5x. And so if you're working through this and you set up a proportion differently, take the cross product test and use that as your comparison. Those equations will always match up. One last thing before I end here, looking at this proportion, again, pay attention to the fact that both the two fractions each have corresponding numerator and denominator, right? 2 centimeters and 5 kilometers correspond because they are both the map scale. Unknown and 8.5 kilometers correspond because they are both the nature trail. The two numerators correspond. They are both measurements on the map. The two denominators correspond. They are both measurements in town. Making sure that you have your corresponding things lining up either horizontally or vertically your proportion will work out. You will be able to solve the problem. So more than one way to go about it. They all have that in common. How about one more completely unrelated example? It takes Sam 18 minutes to type a 5-page report. How long would it take to type an 8-page report? Implicitly in this problem, we are assuming that the rate at which Sam types is consistent and will be for an entire 8-page report. There's always the possibility that the answer is quite a bit longer because after 4.5 hours, Sam is going to take a break and rest their fingers. But I don't have any way of knowing that, so we're going to ignore any of those sorts of concerns as we go about this. Because we are thinking about a consistent rate, we're going to, once again, set this up as a proportion. We're going to think about things that match up. We have 18 minutes and we have 5 pages. That's the report we know things about. We have another report that has an unknown amount of time and 8 pages. So I've set this up corresponding things being each of the 2 reports. The 5-page report that took 18 minutes to type, the 8-page report that has an unknown amount of time to type. My numerators are the amount of time it takes to type. My denominators are the length of the report. So corresponding things in the numerators, corresponding things in the denominators, corresponding things in the first fraction, corresponding things in the second fraction. All of those things are what we're checking to make sure we wrote the proportion correctly. Then from here, 8 times 18 is equal to 5 times x. And I guess I should also take a moment here and point out the length of the report, probably an exact value. Right? The number of pages is exact. Probably. Yes, there's always the possibility that we have a page that only has 3 lines on it, in which case counting it as a full page is a bit of a stretch. But I'm kind of thinking about this as an assignment, where your teacher told you to write a 5-page report. So you've written your report and you're typing it out and you're hoping that it's 5 pages. And if it's not 5 pages, you're going to work on it to make sure that it extends to fill all 5 pages. Likewise, an 8-page report, I'm going to assume we're going to be filling 8 pages to call it an 8-page report. So we'll call those page lengths exact values. The time, on the other hand, probably measured to the nearest minute. That is an approximate value. We will use that as a rounding tool if we needed to, but I don't think we will. All right, 8 times 18 comes out at 144. Yeah, I could round that, but I'll just call it 144. That's fine. Then I'll divide by 5 and get 28.8, but I'll round that and call it 29 as the value of x. Again, looking at that significant digits, I reported this time to the nearest minute, so reporting this to the nearest minute as well. And why not write out your solution in a complete sentence, something like, it would take Sam 29 minutes to type an 8-page report. All right. These two problems are very drastically different from each other, but I think that they do a good job of conveying the scope of what we can do working with proportions. Proportions themselves can be further generalized or maybe further specialized and give us a couple of other problem-solving tools that we'll be exploring in the future. But for now, I think this is a good place to stop. So, as always, thank you for joining me, and I'll see you next time.